we're going to continue our discussion of projections, and I want to mention this theorem from your book. It's 11.6, and it gives us a new way of calculating the projection. And so it says if you have vectors u and v that are non-zero vectors, then the projection of u onto v, is the dot product of u and v divided by the magnitude of v squared times the vector v. So let's look at a problem where we try to find this projection vector. So I want you to find the projection of u onto v, and the vector component of u orthogonal to v for the following scenario. U is going to be the vector 3i minus 5j plus 2k, and the vector v is going to be 7i plus j minus 2k. So we're going to start with the first thing we were asked for is the projection of u onto v, and we're going to go back here and use this nice formula that we have to find it. So W1, that's the projection, W1, the projection of u onto v, we're going to use this formula, u dot v over the magnitude of v squared times the vector v. So let's start by calculating. We're going to need a few things. So let's start by computing this dot product. We're going to need u dot v, 3 times 7 plus negative 5 times 1 plus 2 times negative 2. You add that all up, you'll get 12. And then I also need the magnitude of v squared. So that's just going to be 7 squared plus 1 squared plus negative 2 squared, or 54. So I'm going to plug these two things in here into my formula, and I'm also going to need the vector v. So this vector, W1, it's going to be 12 over 54 times the vector 7i plus j minus 2k. And if you distribute and simplify it down, you'll get the vector 14i over 9, 14 over 9i plus 2 over 9j minus 4 over 9k. So there's my projection vector right there. Now, I was also asked to find if we go back to the question, I was asked to find the vector component orthogonal to v. So it's asking me to find that vector W2, but remember W2, it's just u minus W1. So take 3i, u was 3i minus 5j plus 2k, and I'm going to subtract this vector W1 was from up here. So 14/9 I plus 2/9 j minus 4/9 k. And if you simplify this down, you'll get the vector 13 over 4i. Sorry, over 9. 13 over 9i minus 47 over 9j plus 22 over 9k. And this is my vector W2, the one that's orthogonal